Assalamualaikum warahmatullahi wabarakatuh. My name is Fikri, and today I will be presenting my device for the second assignment of the subject sensor technologies. So the device that I'm using today is called the Early Fire Prevention System. So let's look at the device. Now, the problem statement is fires will spread rapidly, especially across a smaller room, added with more fire hazardous materials scattered across the room. So imagine your bedroom, or maybe even a storeroom that is more likely to be compact and filled with items. So being alert of the presence of fire before it rages is the key to stopping a bigger disaster. Project objectives that I have set is first to develop a security system suitable enough to detect the presence of smoke and fire from a further distance. Second is to assemble a working prototype relevant to project that gives suitable output according to multiple situations. And finally is to characterize all available relevant features of design project that will tackle problem statement. Now here are the theory and background. Uh, the research that I've done for which sensors that I've used in this project. So firstly is the MQ135, which is the air quality sensor. Now the main function of the MQ135 is to measure surrounding air quality. Its range is different for each gases that it detects. So there is no set value. Now the application, it is mostly used in modified atmosphere packaging, aerospace environment, and transportation industry. Its accuracy ranges from 10 to 1000 ppm, and its cost is between 0.38 cents to $5.60, which converted to Malaysian ringgit costs around 50 ringgit. Now the theory and background for my DHT11, which is a humidity and temperature sensor. Main function is to measure humidity and temperature. Its range for temperature is between 1 degree Celsius to 50 degrees Celsius, and for humidity in a room is between 20% to 90%. Applications are for domestic applications, pharmaceutical and laboratories, agricultural applications. Its accuracy for a temperature is 0.3%, and for humidity is plus minus 2.0%. Its cost between 10 cents and to $10. But I got it for like 7 ringgit. Now, finally, is the LDR, which is a light sensor. Its main function is to measure light. Uh, it ranges between 1 ohm to 1 mega ohm. Its applications are for thermal protection, industrial process control, and fire alarms. Its accuracy is actually unknown because it is hard to determine the actual accuracy for the current state of the device, and its cost is 60 cents, which is 1 ringgit. Now, ideas from several sources. So the first idea that I got was the standard fire alarm, a standard security system used in public buildings, for example, malls, schools, and offices. How the fire alarm works is a person would manually trigger the fire alarm by pulling the lever, and the fire alarm would be activated. Second is the water sprinkler system, a standard security system used in public buildings, for example, malls, schools, and offices, in responses for fire-related situations. So the water sprinkler system activates when actually another device is activated, which usually is a fire alarm. So when a fire alarm is activated, this water sprinkler system is activated to extinguish the fire. But the water sprinkler system does not have a built-in sensor or anything that could detect fire in the first place. And lastly is the smoke detector, a security system effective towards fire detection that is available on the current market and is usually run on by consumers worldwide. Now, the detector are usually used in domestic applications, which are homes or stores. But the flaw of the smoke detector is usually it gives a true false output, meaning even when there's no fire in the area, but it will still trigger due to the true false conditions. Now, what you're seeing here is my block diagram. So my microcontroller that I used was ESP32, but we will discuss about that later. So there are four inputs that I've used, which are push button, temperature and humidity sensor, gas sensor, and light sensor. And for the outputs, for output one, output two, serial monitor, and dashboard. The output 1 and output 2 actually, initially I wanted to use buzzer and LED, but in the end project I just use LED for simplicity sake. So now we proceed on to the input and output devices and the controller board is used. As I mentioned earlier, I use ESP32. The controller board for this project contains multiple sufficient analog pins and Wi-Fi to connect with the dashboard. So the dashboard will give back data that sensor has already measured, but to connect from the controller to the dashboard, use Wi-Fi. So that is why the reason I use ESP32, and the analog pins are actually very useful to have a more accurate data reading from sensors. Now moving on to the first sensor as mentioned, which is MQ135. It is an air quality sensor that is also capable of measuring gas, and its output that I used was LED. Same goes for the DHT11 and also the LDR. Now the dashboard that I've used, the first one is ThinkSpeak, and secondly is Blink. And this is the circuit diagram that I have sketched before assembling my project. As you can see, the push button, the three sensors, and three outputs. Now here are the project pictures that from the actual project that I have assembled. So here's a wired up version, meaning the project when it is given power and when the push button is pressed. Here is a here is the version where it is not power up and multiple wires are actually pulled out so that you can see the sensors more and the outputs. Now, here are the dashboard results that I got from ThinkSpeak. So first is the temperature and humidity. And here is the dashboard results from Blink, which is used for a gas sensor. Now here is the serial monitor from the IDE that I use, which is Arduino. And we have come up to the conclusion. So in conclusion, I am now able to demonstrate the ability to use sensor during practical work, and I am now able to explain suitable sensors for specific IoT application by presentation. Now here are the attachments. So first attachment is coding, and I believe if you wish to read this, you can pause the video and have a reading. And that is all from me. And thank you, and we see you.
Hello, Assalamualaikum guys. Hari ni kita akan mendemo sebuah device yang mana saya panggil Early Fire Prevention System. Jadi sensor yang saya gunakan adalah MQ135, DHT11 dan juga LDR photoresistor. Jadi bagaimana device ni berfungsi is apabila salah satu sensor ini antara tiga ni menemui data, maknanya LED sendirinya akan menyala. Jadi katakan MQ135 berjaya mengesan gas, maka LED untuk MQ135 akan menyala. Begitu juga untuk DHT11 dan juga LDR. Dan apa yang kita lihat di sini adalah sebuah push button. Push button ini apabila ditekan, ketiga-tiga lampu itu akan menyala. Sebentar ya. Itu dia. Jadi apa kaitan nama projek saya Early Fire Prevention System dengan sensor semua ni adalah dia berkaitan dengan api. Jadi kita tahu kalau api berlaku akan merebak dengan sangat cepat. Jadi kita akan cuba mencegah daripada perkara itu agar kerosakan dapat dikurangkan. Jadi seperti mana sistem amaran kebakaran lah. Amaran kebakaran, mereka juga ada mengesan gas, juga dapat mengesan suhu. Dan LDR ni saya actually improvise untuk mengesan cahaya kerana kalau suhu atau gas tu tak dapat dikesan pada jarak jauh, LDR ni dapat mengesan bahawa cahaya yang datang daripada api itu maknanya adalah kehadiran api itu. Jadi saya telah connectkan MQ135 dengan DHT11 ini pada dashboard. Jadi kita akan lihat di sini. Okay, apa yang kita lihat sekarang ni adalah dashboard untuk DHT11. Jadi fungsi DHT11 adalah untuk mengukur temperature dan juga humidity. Dan ini pula adalah blink. Di mana blink ni berhubung dengan MQ135, di mana ia sepatutnya dapat mengukur kehadiran gas yang berada di sekeliling itu. Saya juga telah connectkan ke semua sensor ini pada dashboard seperti yang kita lihat sekarang ini. Itu dia. Allahu Akbar. Allahu Akbar. Okey, nampaknya terlalu laju. Tapi seperti yang kita lihat sekarang ni, semuanya berada dalam keadaan yang normal. Tiada apa-apa kebakaran dapat dikesan. Dan insya-Allah tidak akan ada apa-apa kebakaran yang akan berlaku. Sadaqallahul azim.